Can I present with this? It's like my new best friend.
Have you checked it?
No. It's in the briefcase because my flash drive's not working today. I put it in the briefcase today. That was smart of me, wasn't it?
Yep. If you want to, you can put it on my flash drive later. That was great. Just great.
No, we only have 2 cents.
I think so.
I'm going to do one sweep to see if you have any clarifying questions, and then I'm going to do a really in-depth stamp round. Again, if you need help, skip the order. Since I started from high to low last time, I'm going to go low to high.
Yay!
Okay.
Okay, third period. Everybody pull out your sketchpad files. At least one person should have it open. Okay, so let's see. Wait, where's the rubric? Because I can't see it right now. Okay, so you only need... Oh, you said you gave up on that one.
I put it for up here, it comes within, but not down there.
Okay, so you're saying... Wait, you've changed them. You
No,
don't have,
just the one.
you don't have one to the left.
Well, I just left them the way that they were.
Well, they're not. Wait, this one's your up because you were at -1, 1. This one's your right, and this is another right. So you don't have one that's to the left. So you don't have this.
The conversion factor for that is in the briefcase. There's a document called hints something something something. Open that up so you can look up the conversion factor. So once you figure out this number, you can
So
convert it.
these are in solar radar.
Yes.
And then whatever number we get, say it's like 100, we convert that into meters.
Yes.
The gravitational force between the
That, you have your notes like the homework you did for Mercury, exactly like that.
Okay.
Also in the briefcase, there's a gravity force checker. So after you've finished your gravity forces, plug it in there and tell me to refresh it, and we'll tell you if you got it right or wrong.
Okay.
I'm gonna leave this with you. You know how we have you use this a lot? This is the free fall acceleration or acceleration due to gravity. Well, that was a lie. Okay, that's only true at the surface of the Earth. Once you move away from the surface of the Earth, or you change, what do you call it? Or change the mass of your planet or the size of your planet, this number is going to change. So what that is, the real calculation is kind of similar to your force. It's going to be the mass of your planet times big G, which was still 6.67 times 10 to the minus 11, and so on, divided by the radius of your planet squared.
Okay. That gives us the gravity. Acceleration?
Acceleration due to gravity on your planet.
All right.
So depending on how you chose your parameters, it might be Earth-like or bigger or smaller, depending on how you picked.
Okay.
Okay?
And can we keep this by us?
Yeah, keep that. Gosh, you guys have gotten far. I'm excited. I don't even have a grade sheet for that. That's awesome. Looks like it.
What I did is I made up B and C and then just calculated A. That's what I always do. So say your C was, that's your star, right?
Yeah.
So let's make one of your focal points, say 100. That's not a letter yet.
Yeah. Okay.
100 minus, where's this at?
The star? Yeah. The star? What's that? 4, 6.
4? 4. So 100 minus 4, that is 96, and that is now your
Focal point? Or that's C?
That's the center, actually. Your center for HK.
Wait, but is that going to be in the side that happened?
It doesn't matter where your C is or anything. It just depends on how far you want to go. Then it'll determine if it's in the half zone or not.
Okay. All right.
So your
But what if I want it to be like here? Because it needs to stay inside to have.
yeah, it doesn't matter where your points are here,
Okay.
because depending on how big you make your lips, it's gonna stretch itself.
Okay.
Okay, so your center is at 96. Where's the Y that you want it to be in?
The Y, so it needs to be like here.
No, the Y.
Oh, the star?
Yeah.
6.
So 96.6. That's your HK.
Okay.
That is very important to know. Meaning that C. God, that's annoying. 96 minus 4. Is 92. C is 92.
Okay. Why did you subtract those to get C? Why did you subtract those?
Because that gives you the distance between your star and the center.
Let's
Plot these.
Why did you use 4?
That's the X, isn't it? Yeah.
Oh, and H. Okay, I get it.
Let's go ahead and plot these. The first one we said will be a 100, right? 100 tab
It's gonna go right here.
100. Okay, there's your focal point. Then in between that. Oh wait, I didn't divide that, did I? No. Whoops.
Why do you have to divide to get half?
Yeah,
in the middle?
averaging. That's why it seemed weird to me.
So the H is gonna be different now.
I meant to average those. I'm sorry. What is 9 divided by 2? That is
4.
6, 9. I mean 2, 4, 6.
4. This is 1. 44.
Yeah, 4. I can't do like banks.
So it's gonna be 44.6.
Okay. Let's try that.
That looks right though. Oh no, that's the. Okay,
No,
that's
wait. That seems a little slanted. Cause see, it doesn't look like it's in the middle.
It does.
We did 100. Look, it's kind of.
Maybe we.
Oh.
So right now, here's what you have. You have your star to the left, and your center is in the right. Yeah? So if you have your star where the center is to the left, then that would be another one.
Right.
And then this last one, you didn't move it up or down.
I'll check.
The
'cause I could've
star
sworn I
is
did.
your focal point, or the star is your center on that last one, the purple one.
Okay, I'll check.
Okay. And so you have like 0. So the last one's wrong also because it's centered on your star instead of the focal point being the star. So the first one, it's just not a focal point. The second one's okay, and then the third one's wrong. So you're completely inside, partial. Your inside and outside is okay, and then you're completely outside, you need to fix. And if you're going for advanced, you need to fix that stuff too.
Okay.
Okay?
Okay.
All right.
Let me see 2.21. Oh, wait, you're waiting for your ellipses to be drawn before you can do that, right? And I already gave you credit for your 5 characteristics, right? Yes. Anything more? And I think I gave you credit for the effect of M and D. So a lot of the stuff you're just waiting on that. Okay, so I'll come back to it.
Center of our planet, center of the star. So we need to know the radii.
Because if we do it now, and then she comes over here, and then we're just gonna have to do it again with the solar radius.
No, why would we get
The radius plus the radius, you just add it up with let's add it to the number that we're trying to calculate.
So you're going to change your focal points to one up here and one down here to make it vertically
Well, you mean
higher.
focal point 1 right here and then the middle one?
Yeah, because that's all it's asking is that you make the vertical one bigger than your horizontal.
How do I make it to where it's on its side? The circle's on its side instead of like... Oh, I think I got it.
Look, I'll draw a picture.
Oh, I think I got it. Like this?
Yeah, make it like that, like an egg.
Okay.
Make it like an
And-
egg.
You just switch these two numbers?
I think so, yeah. And then you should be able to do it. Yeah. If you need help,
Oh, I see. Did you put that 10,000 on it?
Well, how can I get this completely out of the habitable zone?
Here's the equation right here.
Like,
I believe so.
Then you just have to play with the numbers. Really, it takes a while. Like what I did, it took me a few times to get the numbers just how I needed it. Yes, Mariah?
So you think banks will accept this?
Yep, it's out of the habitable zone. And I'll tell you right now, this is a frozen wasteland. You know what? It's a frozen wasteland. Now, this year is beyond boiling point, and then it's got violent.
Where's your equations?
I don't even place up.
No, the ones for your circles.
Probably. Wait, what circle? Oh, you probably have to zoom in. Are you talking about our planet?
No, because the equations.
Your equation for our circles are? What? The equation for our circles?
They're all right there. Wait, what'd you do with them bangs? What did you
The
do?
question is, what did you do with them?
No, that you zoomed in too much and now
I
they're
didn't zoom
gone.
into anything.
He didn't.
Who zoomed? There they are.
See,
but
why are your
No,
equations
those
way
aren't
over
it.
here? These are for your circles.
Those are old ones.
For your circles?
Oh, those are the hidden.
Ooh, she's like.
Goodness, bangs. What did
All right, I'll come back when you have it all situated.
Where did they go?
I don't know.
Who zoomed in?
Bank.
They're all the way to
There's
the
our
left.
spot.
Look at this. They're right there.
I know, I need the equations
What do you mean the equations
for your
what?
circles.
They're right there.
No, those are for your ellipses.
For our circles, what circle? You mean our habitable?
That, among other things, which is probably what I just scrolled over to.
No, actually, it's right here. Look, display, show all hidden. What?
And let's see if these are not the same ones.
They're not the same ones.
Then why are they there?
Oh, those
Oh,
are
do
the
you
ones
want to
for
move
old
my back?
ones.
You want to move my back? Okay, yeah, it's okay.
Those are the old ones that I don't see. Those were the ones that I had lost. They are the same, but I had lost those when I zoomed in because I couldn't find them.
Why are you
Yeah.
going back there?
Why are you going
Because
back?
I'm just going to show you.
See, they disappeared on me.
They didn't disappear. You
I
just had them
couldn't find
highlighted
them.
when you zoomed.
You know how long it took me to find them?
It took me 30 seconds.
Remember the conversion factor?
Why don't you just copy and paste and then delete those and then put them over there?
I don't know. Would that make you happier?
It would be faster.
Maybe.
Look at you. Look at what you did.
Yeah. Well, it would be faster if you just had them all
It would be
where they're
easier if you
supposed
just
to be.
looked at the ones that were already there. They're the same.
Okay.
But I just have them color coded differently. That's all.
Okay.
You-
But now it's like they're flying in to where the other ones are.
That's all. I'm just gonna read the
Where is this anyhow? By the way, you guys have really weird numbers.
Really good?
Weird.
Oh. Wow.
Like where everything is.
multiplying.
Okay.
Someone hand me a cat.
Oh.
Okay. So now that we've got this.
Dude, they're the same.
Okay.
And they're
Wait,
color-
why did you put this number? This is the right
Oh.
Yeah.
Okay, so you're centered at 6110 and
What?
you're centered at 6110
Our center is
for your
at
star.
Our star?
Let's just
It's
stop.
right here. 61, 60.
Hold on. You're centered at 6110. And let's see. So the first one I'll check is this.
139 times
Okay, so 22 and a half is your C value.
9 parentheses times 1, 2, 0, 5, 4. I will appear momentarily.
Okay, so this one moves to the right, and then that's, yep. Okay, this one also moves to the right.
I'm coming. I hurt you. 1 point. Wait, no, that's an X.
Okay, and then last one.
just gonna get him here. Alright. Have you seen Jesus? He has one like this, only it illuminates. I'm coming.
Okay, this one moves to the left, but you don't have one that moves up or down.
We have to have one that moves up or down.
If you want advanced,
Yeah, well, right now we're trying to get it done before we do advance.
okay. 50 squared.
It's okay, babes. We're gonna get there.
Okay, so as far as your equations, they all have your star as the focal point. One's half, one's completely inside, and one's outside. They're not within the boundaries, so you missed the 2 advanced criteria, but you have the proficient criteria.
Again, I want to get it done first.
Okay.
Work on it, maybe.
Thank you, babe.
Thank you
Welcome.
for checking in.
So for your table, I want this to be in meters.
Okay.
Same with this. You only needed to do closest distance.
Oh. Okay.
Okay. And have you plugged this into the gravity force checker to see
No,
if it
we're
works
about
out?
to.
Okay, so plug that in. So you're just going to change this to meters and have it in scientific notation.
Where is that thing in the brief? Is it in the
It's in the briefcase under project resources. Okay, let me look at your sample calc. Uh-oh. Don't forget the distance in the bottom is squared.
Oh, wait. Let me check. I might have done it.
Also, you're missing big G. The
6.67.
6.67 times 10 to the negative 11.
It's on the... Okay, so yeah, it's
Like,
going to be up here.
it
and
looks
then-
like these are your masses.
Yeah.
This looks like it's your distance. Don't forget to square this distance, and don't forget big G.
Okay, and the big G goes on top, on here?
Mm-hmm.
Okay.
Do you have 2.35? Okay. I think that's a typo. Because you said when the mass increases, the gravity increases. When the mass increases, it
Oh, yeah, it's
decreases.
a
Okay, so you'll fix that.
mass increases the gravity.
It is a direct variation, you're right.
Mass increases. Here, decreases.
Yeah. The off, I noticed that was happening in other Google Docs. Try,
Okay.
if the offset is off, try refreshing the screen. It could be that you're zooming in and out, and Google just never made the adjustment. Okay.
So let's see, we're centered at 4, 6. This one can't have your star as one of the focal points. Your star's in there.
Yeah, that's what I'm saying. Yeah, right?
Let's take a look. So first of all, okay, this one moves to the right. This one's also moving to the right and moving to the right. Okay, so we're skipping that advanced criteria. Now let's check. So right now, you're centered at 4, 6 for your star's at 4, 6, right? So here's your star, and you're moving your center of your ellipse to the right of your star. So your C distance is the distance from the star to that center. So for example, if you're at 4, 6 and you move to 102, 6, 102 minus 4 is 98. So this C is 98 for this one. Okay? So 98 squared, which is your C, plus your B squared, which is 70 squared, should equal this value, which you have written as 98, but it doesn't calculate.
Wait, why is this 98 too?
I don't know. It shouldn't be because, for one, it's smaller than your C, which shouldn't be the case. If your C value is 98, well, actually you have it set equal. You have your major axis is the same as your focal point. So that's this one. See how it's on? The
added that last part of
and that doesn't make sense because that would mean that for this to calculate, your B value has to be 0,
yeah, you give me that.
which wouldn't be an ellipse. Okay, so you're gonna have to change one of these. I would. You just wanted this one to be the partially in, partially out, right? So I would say get rid of that 98 and calculate what that A value should be. Okay? And then you'll have an ellipse that has a focal point at your star and is partially in, partially out. Okay? Let's check this one. So you went to 30 from 4, so your C value is 26.
Is there gonna be concessions for the NHS thing?
And 26 squared plus 250.
Fine, I'll check.
That one's off also. So check those. Check and make sure that they work with the A squared equaling the B squared plus C squared.
Okay.
So I'm going to assume that that one is off also. I'm going to give you partials for all of those. And then when you fix them, I'll come around on another round.
Okay, so we're solving for C on most of these because the C was off?
No, A. A is this number. This is if C's not in the equation at all. If you take this number and you subtract that number, that gives you your C. So 102 minus 4 is going to give you 98. So 98 is your C value for this one. 24 is your C value. Wait, 26 is your C value here. Wait, did I calculate that right? Let me double check that.
That's a planet with a radius that's 18 times the star. Yes.
Okay, yeah, I did, and it's off. What were we saying, Naima?
So in the equation it's A,
That's 18 times bigger than
but it's also C when you subtract from the center point
No,
to...
no. In the equation, this is H.
as is, like Jupiter.
Yeah, but it's 98 A in the equation, right?
Yeah, make
No.
it comparable.
Hold on. Let me borrow your pencil. You have what? Y equals K plus or minus the square root of, if this is a, if it's a wider than it is tall, then this is going to be b squared times 1 minus x minus h squared over a squared. Because a is the major radius and b is the minor. If it's taller than it is wide, then this a and b switch place. So if it's wider, this number's bigger. If it's taller, this number's bigger.
Okay.
Okay? So h is the x-coordinate of your center of your ellipse, right?
Okay.
And here, h is the center of your star, or the center of your circle, which is the center of your star. Okay? So if you do the difference between those, if I've only moved horizontally, the difference between those two h values is how far you've traveled from your star to your, where's this one? At 102? Okay, so the difference between those two is your C value from the star to the center. Okay?
Yeah.
That's why the C is not in this equation, and that's why I was subtracting to get that.
Okay.
Okay?
Yeah.
All right, any other questions?
I don't think so.
Okay, I'm going to put in your partials.
Is the mass of the sun 1, right? When we're
I don't know,
doing-
you picked that.
Oh yeah,
This
so
is the mass of your sun.
it's a simple one.
The solar mass of the sun is 1 by definition. That's where we got that from.
And so when we're doing the gravitational force between the sun and the planet, we just use 1 for the mass?
No, you have to convert it to kilograms first. Use the conversions I give you.
Okay.
So what you need to do there is, since it's a positive 24, you take this decimal and you move it to the right 24 times.
Okay.
So you've got a ton of zeros behind here. Since you can see 4 of the digits, there's going to be another 20 zeros after this.
Alright, so.
Does that make sense?
Yeah.
Okay. That's why it's not a real number in the calculator, because there's not enough spaces.
That makes them actually need your help.
All right, let's do
How
this.
do I do the up and down one? I'm still stuck on that.
Okay, so
I did it, but it's wrong because I had to make up points in order to get it to actually go around the half of the zone.
So let's take a look. So the difference is between these and this one is you're changing the y, right?
Of the center?
You're changing the y value because you're taking your star value
Yeah.
and you're changing the y value. You keep the x value the same, so the x value is the same, right?
I thought we weren't able to move. We shouldn't move the star.
No, the star doesn't move. I'm just telling you what you've already done. See how the y values changed from your original center? So you went from 5 to 105, but your x value stays the same. So if this is your star, where is this one? Oh, it's this one? You moved it up.
This is the big one.
Yeah. So you moved the center of your ellipse up, but you didn't change the x value. So that way your major axis goes through your star. Okay? What part were you having a question about on that?
I don't know if I did it right.
Okay, well, let's see. So first of all, you moved it up 105. So your C value is 105 minus 5, so it's 100. So your C value is 100.
Oh, okay, so I did do that right. Look at that. Cool.
All right, let's see.
This is right.
I found out my problem.
Okay.
It looked like this is right. Ish.
But your numbers don't calculate.
For what? Or how do I find...
So remember, your C value, since you have it vertical, your C value is the distance from your star to the center. Yeah? Okay, so your center's now at 105.
Oh, so C would
Oh,
be
sorry,
100.
6105. So here's your center, right? Yeah, so yes, your C is 100.
100 squared plus my B.
Now, which one did you set first?
What do you mean? Out of these two, I put that one down first.
Okay, then that's your A. In this case, it's A because it's the bigger one. See how when it's vertical like this, the taller value is here? See, A is here when it's vertical. A is here when it's horizontal because this is longer.
Didn't I give you credit for that? Yeah. I already marked that as you're done.
Oh, okay.
For, let's see your mass and radii. 2.23. Do you have 2.23? No. No, yeah. Let's see 2.34. Okay, I'll give you partial for beginning this work. It will take time.
Yeah.
But make sure you're not doing those numbers, but the numbers for your actual planets. Yeah. Do you have 2.35?
I think. Oh, okay.
Yeah.
And we already got stamped for that.
Okay. That looks like it's fine. Wait. What did you get for your center to center distance?
We just calculated it in
Okay.
already.
Okay. Then use just the regular gravity checker with those distances to check your forces.
Okay, and then for this one, do you want us to round that to the nearest 100?
Mm-hmm. But I think my gravity checker will be okay if you don't. If you don't do that. So as long as you have like the decimal number and the exponent, it should be able to check it.
Can you refresh the thing?
Yeah.
Is there except to make it go the same?
There's a few ways you can adjust it. Yes, you can. So for example, you know how we just recalculated this axis based on this one? You could have left this at 500 and calculated what this axis would have been.
Ah, okay, so I'll just do that then.
Yeah. Okay, so you've got partial on the outside. The other two are fine. You've got your advanced there, but not the one for being close to both boundaries.
Do I need to do that just, can only one of these right here be that? Like, or do all of them have to?
Oh, no. Only one could do that.
So it could only be that first one?
Yeah. This one. Wait.
Yeah, this one. These two right here.
Yeah.
So it's all color-coded.
Yeah, so if you wanted to get that other advanced, you would adjust that one. All right, so I'll give you your stamps.
How do I find out how many solar radii is Earth? Do I use the equation?
Oh. In the briefcase, I have a document called Hints. It will give you the conversion from solar radii to meters.
Okay.
Is that what you're trying to do?
Wait, thanks.
You don't want the Earth's radius in solar radii. You want it in meters.
Because I want to see, because I know our planet should be smaller than our sun, which is a certain number of radii,
Yeah.
and I want the planet to be less than that. See comparison, basically.
So we know our sun is 1 solar radii.
Yes.
So if you look in the briefcase, you can convert that to meters. And then you can probably find the Earth in meters too. Okay. So it's under Hints. gravity hint.
So skipping that advanced criteria.
Yep. Maybe if we add one later. Can we have more than 3?
What? No.
Why?
Why would you? No, that would be really hard to see everything.
Okay, we'll have 3.
Okay, so, I mean, you could adjust those, but
I'll do the math.
we've got 36 squared plus 300 squared. Okay, so your red one is fine. It's got your star as one of your foci. These are all going to be pretty similar then. Okay, your blue one's fine. And yeah, it seems to meet that criteria. And 36 squared plus.
Oh my god.
Okay, so all 3 of those are okay. Next step might be to go for advanced, or yeah, you can go for advanced, or you can start working on section 3, or some combination.
Oh yeah, that looked hard. I didn't know what to understand it.
To start on it, you probably have to check in with Trinidad to ask her about it because she has the top part of section 3. And then if you do my part of section 3, you need a workshop because you don't know how to do
Yeah,
it.
that's the part I know because she told us.
Okay. Let me put in your stamps first.
Thank you, guys.
You're welcome.
Pick your 5 favorite. Don't use anything that has to do with the habitable zone because you just discussed that.
Okay.
So pick other things.
Okay.
Okay. Okay, go back. So that's how you're going to do 2.22. For the next one, let's see what you got. This, I think, is in meters. This, I think you're missing powers of 10. Because
Wait, those are in powers of 10? Oh gosh.
there's got to be powers of 10. The current masses you lifted are like bowling ball masses. Like I can lift your planets. I could bowl with your planets.
But all of her calculations are.
Yeah, check it. I think they're in the wrong units. Fix. Your planets are really light. Fix your masses.
Okay.
You weigh more than your planets.
That's good.
Hey.
Huh?
That's not good.
I'm saying an average person is like 60 kilograms. There's no way Mars is six kilograms. No way. No way. Look that up again.
Did you say you weigh 6 pounds?
Oh my God.
A lot of kids do.
But kilograms equals 2.2 pounds, so that would be like weighing like 13 pounds.
So does he still weigh more than us?
Yes, the Earth weighs much more, has much more mass than us. I'm
Do you remember
positive.
what website we used for that?
Just look at it. You're probably missing times 10 to some power. And it's a big
Now
power.
that happened, all her calculations are obsolete.
Yeah. Sorry.
Yeah, all that work.
Oops. Well, your explanations were good.
And we know the process of scientific notation.
Yeah.
Wait, is
Now
this
you know
right?
why it's important.
No, what I wrote.
Oh, I thought you
Huh?
meant the
Is
numbers.
this right?
Like the way you're comparing to Mars, Venus, and Earth is fine. I'm giving you full credit for the explanation. What I'm taking off for is just the masses are way too small.
This
And
is not our planet, so it's these.
Yeah, they're still too
Oh,
small.
they're way
Yeah.
too small because of the way you wrote it. And your radii, what units were your radii in? I think they're reasonable.
I don't remember.
They're not solar radii, that would be too big. Double check the units on that. So add units to your masses and radii. But your process for picking them was fine. It's just a unit issue.
What is force measured in?
Newtons. Oh my God, I have planets that are bowling balls. I have masses that are ohms. No, it's not. No, it's
Hold on, it's on the River Church. Oh,
who made all the force laws? It's named after that dude.
Did you guys have the 10th power on your masses?
To the 10th.
Oh, look, here's what.
Why am I not knowing
You
this?
should know this.
Who made all the force laws?
Who made all the force laws? They
made all the
named the unit of force after him because he did so much work on that.
Who did all the force laws?
Once you hear the unit, you're gonna be like, oh my God.
Is it the
Is it?
what? Sorry.
It's
Is
named
it-
after a person.
What's the?
No. down.
What's the
Unit of force.
The unit of force.
You know what the unit of force is? It's named after the guy who yes.
Wow.
his
Oh
first
my
name
gosh.
is Space.
Isn't it Isaac Newton?
Yeah.
Oh my god.
That was
I feel
amazing.
stupid now. I really do.
You'll never forget that.
Not wrong.
All right. So we know the acceleration due to gravity on is 9.8. This is only true on the surface of the Earth.
So it's different for our planet.
Yeah, and it's also different on our planet if we go higher than sea level. Because the real equation for this acceleration is big G, like the same one that goes in force, times the mass of whatever's pulling you in, so it would be the mass of your planet that you're analyzing,
I wouldn't be able to stand that.
divided by d squared, which is distance from center
We just do the same thing.
of planet
All right, I'll do Capricorn.
to whatever height you're at. So for now, let's just say you're on the surface, so it'll just be the radius of your planet. Same units. This will be in kilograms, and this will be in meters, and your overall units will end up being meters per second squared. So it'll be interesting to see for the parameters you pick what that little g is going to look like on your planets, because then you'll just know by just comparing it to 9.8 if it compares well to what we experienced.
So then,
Also, Kevin noticed.
should be close
Let
to
me
the
see
one
something
that-
in the rubric. Kevin noticed that there was an error in the rubric, and I need to fix.
there's an error in your
Yeah.
gravity checker thing.
Oh, there was one thing
Yeah.
that was like,
This is the same. Ignore
Yeah.
that. Ignore that.
yeah, that was the same one.
So this is what you're about to do.
It's the same amount of numbers, right? So our
Yeah, and then everything's fine. Just ignore this. I don't know why. That's it. Okay.
Third period. So I don't have time to make another round and see all of yours, so make sure that you have a copy of it saved in the share folder in the J drive. Okay, who else needs the workshop on section 3 to get started with that? These are two new formulas that are going to be similar to what we've done before, but they're different. So we have 4py equals x squared, and this is for a vertical parabola, and this one, or a vertical vertex, and this one's for a horizontal vertex.
Right?
Oh, so sure about that one.
Okay.
Well, yeah, that one looks weird.
I might get this.
Okay,
Is that for that other thing?
yeah, this is for section 3. Okay, 4 is a specific constant that goes along with this. P is going to be the distance between, let's say I did one of these, a vertical vertex. So this distance here is P.
So the distance between.
It's the distance from the vertex to your focus point.
Does that have a name?
P.
Yeah, but does it have an actual?
For the distance? No, it's just distance P. Just like, I mean, you could call it the distance from the vertex to the focus point. Just like we have C, and it's just C, but it's the distance from your focus point to the center of your ellipse. So this is just P. So it's pretty simple. If you solve these, let's say we were doing this one so that we could graph a vertical. So if you solve this one, y is simply x squared over 4p. Okay, so y equals x squared over 4p. So if I want to graph something, let's say I wanted to be, I don't know, 16 units away. So then my p is 16, and then this is 4, so I just do 4 times 16, which is 64, right?
Yeah, 64.
Yeah, so we've got y equals x squared over 64 if my p is 16, okay? Does that make sense? Mm-hmm. So it's pretty simple to graph, and they're not that complicated. If you do section 3, you're gonna have one that's centered around, okay. So you're gonna have one that's vertical and it goes around your star, and then you have different let's say this one's the one that's habitable, which doesn't make sense. It should be like maybe shaded over to one of these. Okay, let's say that's your habitable one. Well, if this has a horizontal major axis, then you'll pick a point like this, and then you'll have another one that comes
So
in
do you
like
just
this.
pick any point that's on the...
You've got two to choose from. And so I'll be checking these equations to make sure it's the distance that is specified away. And it's based on your star diameter. So keep that in mind. So this is what this is. You know how you have your star and you have your habitable zone?
Yeah.
And then you have one of them that's completely within the habitable zone. So along the major axis of that one, there's 2 points where it hits the major axis, right? So you're going to put a point at one of those sides, and then you're going to have a comet that comes in. Nope, it's not a comet, it's an asteroid. Because it's not elliptical, it's not going to come back. It just gets caught in the gravity and gets slingshot around. Okay?
Or it hits it.
No, it doesn't hit it. So that's what happens on these. This one, it's going around your star. So you have some other asteroid that
And it
comes.
could also hit the planet.
Did I give you green for 2.23 yet? Let me see it. That's good. That's fine. Was that calculation advanced or proficient?
Advanced, right there.
What's your
You told us to just put it in with the other one
Because when you added those two radii, did the distance change all that much? Little enough that when you rounded it, it was pretty much the same number?
No.
Can I see your two different distances? Oh, I see what you did. You built it in, and then you entered it rather than putting it separate radii. Yeah, that's fine. That's fine.
Wait, that's advanced.
Yeah. Just when you do your sample calculation, just show me an example of how you added those three. Okay? So I'll be looking for that to give you full credit on your sample. Okay.